Hello, students. So today we learned about radicals with division. And we learned that when we have a radical in the denominator of a fraction, then we need to rationalize the denominator. We need to rationalize it, which means we need to make it not be a square root anymore. And so the method for rationalizing a fraction that has a radical in the denominator is to multiply the denominator by the radical itself, square root of 2. Whatever you do to the bottom of a fraction must be done to the top of the fraction if you want to keep it equivalent. And we do. We just want to come up with an equivalent fraction that does not have a radical in the denominator. And this is the method that is used. It's called rationalizing the denominator, and you multiply the radical by itself. When we do that, the square root of 2 times the square root of 2 is 2. 3 times rad 2 is just written as 3 times rad 2 like that, and it's done. I'll skip down to number 4. We have a radical in the denominator, and so to get rid of it, I'll multiply it by itself, and I'll also multiply the numerator. It's as if I'm multiplying by 1, so the fraction that I get after multiplying by rad 3 over rad 3 will be an equivalent fraction. I get 2 rad 3 on the top, and rad 3 times rad 3, remember that's the same thing as rad 9, but that's a perfect square, so that's 3. And that's the answer for number 4. Now on number 5, we have a radical in the denominator, and we also have a coefficient for that radical. But when multiplying the denominator to make it rational, we only need to multiply it by that square root of 5. Only multiply it by the radical itself. You don't need to multiply the 4 also. So we're just going to multiply top and bottom by rad 5. And what we get on the bottom is 4 times 5. And on the top we get 3 rad 5. Let's simplify that. 3 rad 5 over 20. And I don't see a common factor between 3 and 20, so it's done. I'm going to go ahead and do number 7. Here's a rad 5 in the denominator. I'll multiply both top and bottom by rad 5. So on the bottom, rad 5 times rad 5 is just 5. And on the top, rad 3 times rad 5 is rad 15. And rad 15 over 5 cannot be simplified. Rad 15 does not have any perfect squares as factors. You could try to make a factor tree and you'll end up with 5 and 3 as its prime factors, and there's no pairs. So the square root of 15 is simplified and 5 is fine too. Okay, I'll skip down to number 11. I'm going to multiply the bottom by rad 5 and the top also. So the bottom becomes 5 and the numerator becomes 2 times, 2 is on the outside, and on the inside of the 2 radicals will become 20. So now I no longer have a radical in the denominator, but I do have some simplifying to do. The square root of 20 can be rewritten as 4 times 5, and that 4 can be broken down to 2 times 2. So that's equal to, I can take out a pair, one of the pairs, 2, and what's left is rad 5. So in the numerator, I'm going going to erase this so it's not in our way. In the numerator, we have 2 times and then 2 rad 5 because rad 20 has been rewritten all over 5. And then the numerator becomes 4. 2 times 2 is 4. And radical 5 stays on the inside, and we have 5 as the denominator still. And now it's simplified as far as we can simplify it. Now number 13, 14, 15, and 16 show us the division property here of radicals. This whole square root, this whole radical sign is covering this entire fraction, but we can rewrite it as the square root of 4 over the square root of 16. The square root of 4 is a perfect square, that's 2, and the square root of 16 is 4, and that can be simplified from 2 over 4 to 1/2. I could also just directly simplify what's in here to 1/4, and that would be the radical over 1/4. And then I can take the square root of 1 and the square root of 4, and I would still get 1/2. There's more than one way to simplify, often with these radicals. I'll leave 14, 15, and 16 to you. Actually, I think I'll do number 16 because it's a little different. The radical sign covers this whole fraction. I can rewrite this as square root of 12 over square root of 4. And a square root of 4, well, 4 is a perfect square, so I can make the denominator 2. 12 is not a perfect square, but I can at least simplify it. And the square root of 12 simplified is 4 times 3. This is a perfect square, so I can take out the square root of it, which would be 2. Remember, this is 2 times 2, so I'm taking out the 2. And what's left is the 3. So I'm rewriting the square root of 12 as 2 rad 3. And now I can simplify a little bit further because 2 on the outside in the numerator and 2 in the denominator leaves 1. And so the final answer is rad 3. (17) through 21 require the special skill of multiplying the denominator by the conjugate. And remember, the conjugate is that special binomial that has the same first term as the original binomial, the same second term as the original binomial, and then the opposite sign in the middle. So I'm going to multiply the denominator by the conjugate, and then of course I will need to multiply the numerator by the conjugate as well. When multiplying binomials by their conjugate, the middle terms drop out. So what we are left with is the first 2 terms multiplied together and the last 2 terms multiplied together. So 2 times 2 is 4. And then the negative rad 3 times a positive rad 3. Well, rad 3 times rad 3 is 3. And we have a minus because we have a minus times a plus. And we're not even going to worry about the middle terms here. We're not going to use the entire FOIL. So 4 minus 3 is in the denominator. In the numerator, we'll distribute the 2 times 2, which is 4, and the 2 times rad 3, which is 2 rad 3. And we can see that 4 minus 3 is 1. So we're going to end up with a fraction over 1, which means we don't really need to write that, but it's 4 plus 2 rad 3 over 1, and the actual answer is just 4 plus 2 rad 3. So multiplying by the conjugate